Hello, welcome back to Diary.io. In this video, we're going to be talking about Inode in Linux. Now, Inode is one of those elementary and fundamental concepts that's very important to understand before we start doing very advanced stuff. As we've already seen in most of the hands-on we've been doing it in the past, that everything in Linux is based on files and directories. For the Linux kernel to be able to do what it's meant to do as an operating system, it needs to be able to create files and read files and manipulate directories. Everything is based on the directories and the files. And the concept around inodes is the fact that every file has metadata. And what do I mean by metadata? Metadata simply means data about data. Now that may not make a lot of sense to you. Let's take a human being as an example, a human being with the name Peter. There are so many ways to identify Peter, but if you want to call out Peter, the only thing you're going to have to do is to call Peter. But how about the other things that identify Peter, such as his skin color, his eye color, his height, his hobbies, and maybe even the color of his shirt? Now, these extra information about Peter are the metadata about Peter, but the name itself is Peter, which identifies that individual. And so every file on the Linux file system has both the file name itself and also metadata about the file. So in this video, what I'm going to be showing you is how to differentiate between the file and the metadata of that file, which are stored in what is known as the inode entries. Now, like I said before, inode entries are metadata about a file. So what will metadata about a file be? Then we'll be talking about the size, the device ID, the UID, the GID, the mode, the timestamp, and a pointer to the data itself. Now, I'm not going to go deep into what UID, GID, mode and all of that is, because we'll be talking about that in the next couple of videos. But at this point, you just need to understand that these are extra data about a particular file. So what we're talking about here is the fact that there are two tables that store information about a particular file. So we have the inode, which stores metadata about the file, and also we have the file table itself, which stores the file name and also the inode number. Essentially, when you type ls on a particular file, so we have a file already called, let's see, I need to go into the desktop, so let's go to desktop and do an ls on a file called learning Linux. Yep. Now, the only thing that's returned to us is learning Linux, which is the name of the file. How about if I did ls-l? As you can see, we now have more information about that particular file. And what's essentially happening is that two tables have been queried to get this data. The first table is the inode, which has this extra information. The RW there means read write, and that's telling us the type of permission that the file holds, and the user, the group, and we get into all of this information soon. The date, which is the timestamp, and the other table gives us the name of the file itself. And because of this type of architecture, that's why in Linux we can usually have multiple names that is pointed at the same file. So it's possible to have another file called DevOps Linux and another file called Diary Linux, and all will be pointing to the same file. And I'm going to show you all of that in the next couple of minutes. Now, before we go any further, I'd like to quickly show you something about inode. Remember, we used the df command previously, where we see the file system and the mount and all that. And remember when I said if you put a flag of -h, it gives us a more human readable version of the same command, of the output of the same command. So now this time around, I'm going to use another flag this time, which is the dash I, and that will give us information about inodes. So inodes is another element of the Linux operating system that helps us to determine how much of files that a particular file system can hold. If you look at let's take a look at this particular file system, this partition here, which is dev sda. As you can see, it says we can have 622,000 inodes, and we have 234 that is currently in use. So depending on how the partition has been formatted, which we're going to go into in the next couple of videos as well. So there is the XFS, the ext4, ext2, and different types of formatting that we can do on a file system on a hard disk. Each of these formats have a maximum number of inodes that can be configured on them. So depending on the maximum number that your file system holds, that will then determine how many files that your file system can hold. Now let's also have a look at the same file we'll play with just now. If I did ls on learning, okay, it's actually the only file out there. So if I did ls on the learning Linux, it's in caps, that's why it didn't come up earlier. As you can see, it's bringing back only the file. How about if I did ls -i? What's happening is the I, which stands for inode, is telling me what inode number this learning Linux file hold in the inode table. So let's take a look at what's going on here. So if this file, we have an inode of 554825, which has metadata of size, device ID, UID, GID, the mod, timestamp, and the pointer to the actual data. And then we have a file named learning_Linux, and then we have a file table that has an entry of learning_Linux and an inode number of 554825. If I created another file and named it diary_Linux, but then pointed to the same file, but then pointed to learning_Linux, what's going to happen is in the file table there will be another entry for diary_Linux with an inode of 554825. And you might start wondering, but why would I want to have multiple names that's pointing to the same file? Well, when you start getting hands-on with the different projects that we're doing as part of the PBL project-based learning for DevOps, you get to see that there are multiple use cases where applications would need to create links to the same file. The next question is, how do we actually access the inode of this file so that we can see the extra data it keeps about it? Well, thankfully enough, there's a command that helps us to do that, and that command is the stat command. If you did stat on learning Linux, that's where you start seeing the metadata that I was talking about. So we have the file name and the size and device. We have the access, which is the permissions, the UID there. And if you take notes of these, it says links 1, meaning there is only one link to this file. If we created another file that's linking to that file, then this number is going to start increasing. And the difference between modify and change here is that when you modify the data in the file itself, it records the timestamp of when that happened. How about if you change the permissions on that file? Saying who can access it. There's a command we use to do that, which is chmod, and I'm going to demonstrate that to you in a minute. But then this stat or inode information will keep a record of when such data was changed. Right, let's try to make a change to this file and see if there's going to be some information. So learning Linux, and by the way, this learning Linux is I think it's one of those files we've been keeping around to store. I hope you've been keeping a copy of this file on your side so that you keep a record of every command that we've been working on. And by the way, if this is not a complete list of what we've been doing, never mind. I probably haven't been storing everything, but I expect you to be storing everything. So now we have seen ls minus I, we have seen df minus I, and stat command. So we've changed a couple of things here. Let's save this and remember how to use vim in the last video. Escape, colon, WQ, and enter. Now let's run the stat command again, and I'm going to show you a little bit of trick here again. Remember I showed you Control R previously where you can just type in S and it brings back the command. Well, there's another trick I'm going to show you, and that is using the exclamation mark. If you did exclamation and you type in just S and hit enter, what's going to happen is it will run the last command that has S in it. And because I know that the last command I ran was stat, it's essentially going to run the same command, which is stat learning Linux. So that's just one of the tricks to increase your speed on the Linux terminal. Okay, so let's make a quick comparison to what's going on here. Now, what we changed was the data itself. So modify, previously we had 2020-05-26, and today it has changed to 2020-06-03. And by the way, you can see access changed, the access time here changed. The access time also changed here because we actually accessed the file. Now let's clear the screen and do a chmod on the actual file. And chmod, by the way, is change mod, which is the permissions on the file. I'm not going to go into the details of the numbers because there's a dedicated video on that, but for now this is just to change the permissions on this file, which essentially means who can access it, who can run it, who can write to it, who can read to it. And if I hit enter on that and did a stat, you'd notice that the only thing that has changed right now is the change part of the inode. And if you notice previously that it also changed, you can ignore that because before I started recording the video, I made changes to the file, but the concept remains the same, trust me. How about if we wanted to create multiple files that points to the same file? Well, there's another command that can do that, which is the ln, which means link. And what I'm going to do is to link learning Linux to a new file called diary. Let's say diary.io. Yeah, why not? And if I run the start command again, take note, we now have two files that are linking to the same file, like I said previously. And how about if we did an ls on diary.io? You can see it's the same file. So we didn't just create this file and add content into it. It's basically just a file name that is pointing to the same inode that Learning Linux also has. So this is where we're going to conclude this. I hope it's been very informative for you. Don't forget to subscribe to the channel.